Well, welcome. Let's talk, if we can, a little bit. Let's talk a little bit about the standard division algorithm, how we teach division to small children when we get beyond what can be modeled. No one is modeling 512 divided by 4. Nobody is making 512 objects and dividing them into 4 equal piles. No one is doing that. They are instead showing this. And then what do we ask kids to do, right? We ask kids to see how many times 4 goes in a 5 and they write a 1 up there. Well, why? Why do they do that? Well, think about how we model 512. We model 512 like this. That's 512, right? That's 512. So what we want to do is we want to make the 4 equal piles. Well, if we're going to make 4 equal piles, then these go in 4 separate piles. And that's what this 1 is. We take one of these hundreds and put them in each of the 4 piles. So 4 goes into 5 once, and that enables us to remove these from consideration because we've already put them in piles. So then what does the algorithm ask us to do? It says, all right, 1 times 4, and we write it down here, and then we subtract, and that's a 1, and we bring those down, and that's 112. But think about it. What is that 112? That 112 is what's left over once we get rid of these 400s here. What remains is 112. Now we still have to take this 112 and divide it into 4 equal piles. How do we do that? So we look and we say, well, 4 doesn't go in a 1, but it does go into 11. How many times? And then we write a 2 up there. Why? Because we trade this 100 for almost snuck them all in. There. We trade this 100 for 100. Figure not drawn to scale. And so now we're asking, this goes in a pile, in a pile, in a pile. This goes in a pile, in a pile, in a pile. I should probably have used a different color. You'll get it, I hope. So the 4 goes into the 11 twice. What does that mean? That means that we put 2 of these 10s, remember 2's in the 10s place, 2's in the 10s place, that's why we have to write it up here. We put 2 of these in pile 1, and 2 of these in pile 2, and 2 of these in pile 3, and 2 of these in pile 4. So then what do? Well, 2 times 4 is 8, and we write it here. Why? Because this is not 8. This is 80. We removed 80 from consideration. And then we subtract. What is this 32? This 32 is this 32. And then 4 goes into 32 8 times, and I think you can see that 4 will go into 32 8 times. We would trade those 10s for 1s. We'd have 32 little 1s. We'd make 4 piles. Each pile would have 8 things in it. And so we confirm that there is no remainder. There is a 0 remainder. And so we have an algorithm for division that works. It doesn't just work because it happens to work. It works because we are using our place values, considering hundreds first and then tens and then ones. So on the first go around, we're looking at hundreds, and on the second go around, we're looking at tens, and then on the third go around, we're looking at ones. And if young people see that, then they know what's going on. It works when the numbers get bigger. It works when the numbers get bigger. So let's just try should use black here, 4,692 divided by 23. It's the same idea where we say to ourselves that 23 doesn't go in a 4, but it does go in a 46. Now remember, that's not 46. That's 4,600. That's 46 hundreds. So if there were 46 hundreds and you were looking to make 23 piles, each of those piles would have 2 hundreds. That's why the 2 goes there. The 2 is a 200s. That's why the 2 goes there. And then we multiply and subtract. What does that subtraction do? Well, it says that we had 4,692. We remove 46 hundreds. All that's left is 92. So then we ask ourselves, does 23 go into 9? Well, not really. And so we put a 0 over there. Why? Well, if we were left with 92, if we had 92 and we tried to make 23 equal piles out of that, could we put a 10 in every pile? No. We cannot put a 10 in every pile. So there are no 10s in our quotient. But we can do 23 into 92. We would break those up into ones. We'd make 23 equal piles, and each of those piles would have 4. No remainder. The algorithm for division revolves around place value, as so much in our course revolves around place value, because so much of arithmetic revolves around place value. And I hope that this is helpful in showing you why things work the way they do, so that you can show young people why things work the way they do. And I look forward to seeing you soon.